Okay, welcome to lesson 3.3. Today we're going to talk about employing counting techniques. Now that sounds a little, a little basic, but it's very easy to count things if you can see them, or even if you can conceptualize how many you're talking about in your head. But when you're talking about, thousands of possibilities, sometimes you need a little bit of help. So we're going to look at some different techniques. We're going to look at the multiplication rule of counting and how a tree diagram can help with that. And we're going to consider permutations and combinations. Okay, so the multiplication rule for counting says that if you've got a couple of events going on, the number of outcomes for the first event times the number of outcomes for the second event tells you the total number of outcomes or possible outcomes. So we want to find the possible outcomes, number of possible outcomes when rolling two dice, one right after the other. Okay, so you have 6 outcomes for the first dice. Okay, so here we've got a blue die. That's our first die. And then here's an orange die. That is our second die. And so together, there are 36 possible outcomes. Here's some more examples. In the past, an area code consisted of 3 digits, the first of which could be any digit from 2 through 9. The second digit could only be a 0 or 1, and the last could be any digits. How many different area codes were possible? Okay, well, you've got 3 digits, each with a different number of possibilities. If we're talking about 2 through 9, that's 8 different possibilities. Go ahead, draw them out if you need to and count them. And then for 0 and 1, there's 2 possibilities. And then there are 9 digits if you include 0, which they do. So it's going to be 8 times 2 times 10, which is 160. And how many different ways could 4 items be arranged in order from first to last? Okay, well, you have 4 options for the first item. Then one of the items is taken up. So you have 3 choices for the second item. Now 2 of your choices have already been made. So you only have 2 options left for the second one. And then whatever's last and left over, that's your only one option for the last space. And so that gives you 24. We will talk about another way to refer to a product like 4 times 3 times 2 times 1 in just a few slides. Sometimes it's helpful to draw a tree diagram. A tree diagram is a visual display of the total number of outcomes of an experiment consisting of a series of events. So here is a tree diagram for selecting a class schedule. You're planning to take psychology, anatomy and physiology, and Spanish 2. Okay, so you've got 3 consecutive sections to pick of different classes. So you're going to start here, and let's tackle psychology first. There are 2 sections of psychology. So you're going to branch off. You could pick section 1 or section 2. There's 2 sections of anatomy and physiology. All right, so if I picked section 1 for psychology, I could pick 1 or 2 from anatomy and physiology. If I pick section 2 for psychology, still have the choices of 1 or 2 for anatomy and physiology. And there's 3 sections of Spanish 2. All right, so for each of these branches that I've already started, I now need to have 3 little baby branches come off of those. Okay, because we've got 3 options. No matter which path we've taken so far, we have 3 different options for Spanish 2. So now what you can do is count up how many total paths that you've created. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you have 12 total possibilities. Okay, there's some notation we need to talk about. It's called Factorial Notation. If you see N with an exclamation mark in mathematics, that doesn't mean N with a lot of emphasis. It's read N factorial. N factorial is applied only when N is a whole number. N factorial is the product of N with each positive counting number less than N. So down here I have an example of 5 factorial. That's going to be 5 times 4 times 3 times 2 times 1, which is 120. One thing you need to know is that by definition, 1 factorial is equal to 1, and 0 factorial is also equal to 1. Okay, that's by definition. All right, so then 3 factorial is 3 times 2 times 1, which is 6. You can calculate factorials on your CAS. You can enter the number in your scratch pad and use menu, probability, and select factorial with the little exclamation mark. Okay, so now we're going to talk about permutations and combinations. So a mathematical permutation is actually what we usually have if we're talking about combinations. Like your locker combination, there's a specific order to the numbers that you have to get. So you're just going to really have to think about that permutations are where the order make a difference. It's an arrangement in a particular order of a group of items. There to be no repetitions of items within a permutation. So if we list all the different permutations of the letter A, B, and C, you can have ABC, ACB, BAC, BCA, CAB, and CBA. And that's it. Now, if we want to be fancy, we can even get where we list the different 2-letter permutations from a group. And this time we're going to do A, B, C, D. And so we can have AB, AC, AD, BA, CADA, BCBD, and then CDDB, CDDC, okay, and so on. All right. The number of ways to arrange and order indistinct objects, taking them R at a time, is written P and then N, R. You also can do N and then PR. And that is going to equal N factorial over N minus R factorial. So if I want to find the number of permutations of 7 objects taking 3 at a time, it's going to be 7 factorial over 7 minus 3 factorial, and that's going to turn out to be 210. You can also find this out with your CAS. So you're going to do menu probability permutations and then put 7, 3 in the parentheses and press enter. So an application of permutations would be something like this. A teacher has chosen 8 possible questions for an upcoming quiz. And how many different ways can 5 of these questions be chosen and arranged in order from number 1 to number 5? Okay, so we have 8 objects and we're going to choose 5. And so that's going to be 8 factorial over 8 minus 5 is 3. So 3 factorial, which is 6,720. Now, a combination is a grouping in no particular order of items. It's kind of like a combo meal. You know, if I go to Chick-fil-A and order a number 1 combo, I don't care if they put my sandwich in first or my French fries, or if they make I always get a diet lemonade if they make my diet lemonade first. I just care that all the pieces that are there. I don't really care what order they're in, okay? So the number of combinations of N objects taking R at a time is going to be N factorial over R factorial times N minus R factorial. So it's the same thing as permutations, but you have an additional factorial in the denominator. There we go. There's our formula. All right. So there's several ways that this can be written. You can have N and then the C and then R, or people will even use this like tall parentheses with N and then R underneath it. All right. So we want to know the combinations of 9 choose 3. So that's going to be 9 factorial over 3 factorial times the difference factorial. And that turns out to be 84. You can do this in your calculator. You just choose combinations instead of permutations. So if we asked, a teacher has chosen 8 possible questions for an upcoming quiz, and how many ways can 5 of these questions be chosen if order makes no difference? Okay, so we don't care which one's number 1 and which one's number 2, just we're going to consider all the quizzes that have the same 5 questions as equivalents. So that would be 8 factorial over 5 factorial times 3 factorial, and so that would be 56. Okay, so which method should I use? If the experiment consists of a series of stages with various outcomes, use the multiplication rule or tree diagram. If the outcomes consist of ordered subgroups of R outcomes taken from a group of N outcomes, use the permutation rule. If the outcomes consist of non-ordered subgroups, just like with a combo meal, you don't care, it's not a different meal if your fries are put in first and then your sandwich than it would be if your sandwich put in first and then your fries. Of R items taken from a group of N items, use the combination rule. Okay, guys, here's your problems to try on your own. Go ahead and try those. If you have any questions or need any help, you can always email me or drop by my room. I am happy to help you. Thank you for watching the video, and I hope you have a great day, and I will see you soon in class.